All right, in this video we're going to go through all the multiple choice for the extra practice for the Unit 4 test. So number one, the position of a particle is moving along the x-axis is given by the twice differentiable function x of t. So this is the position function. So we know the position at time 2 is 0. The first derivative is less than 0, which when we're looking at that first derivative being less than 0 means that it's moving left. And then the acceleration, second derivative of 2, is also less than 0. So that means that my acceleration is 0, or as I compare these two, they have the same sign, which means it's going to be speeding up. So we know it's moving left, so it's going to be moving away, as we're talking about these pieces here. And then we know that the speed is increasing, which is going to give me the answer of D. All right, next one we're going to try and estimate off of this velocity graph. We're trying to estimate the acceleration at time equals 23. Well, we don't have 23 on here, so we're going to pick the closest values to that, and we're just going to find their slope, because the acceleration would be the derivative of the velocity. So y2 minus y1 over x2 minus x1. And then when we get that, we should get negative 2.1 over 5, which should give me an answer of B, negative 0.242. All right, down on to number 3. All right, so I know that this one has horizontal tangents at 1 and 5 for this graph. This is its position graph, not the velocity, its position. And then it has a point of inflection at 2. We're going to talk a lot more about points of inflection, but that's where it's kind of changing from this like valley shape to this hill shape. That's where that happens. So as we look at this one, we're looking for when is the velocity positive. So velocity of my position graphs would be slopes. So when are the slopes positive? And the slopes are positive from the minimum up to the maximum. So that's going to be from 1 to 5. All right, a cube with edges of length x centimeters has a volume of x cubed centimeters. The volume is increasing at a constant rate of 40, so dv dt is going to be 40. The instant when one of the sides is 2, what is the rate of change in x? So we're going to just use this formula, and let's take the derivative, dv dt equals 3x squared dx dt with respect to time on all of those. And then just fill in what we know. We know dv dt is 40, and x is 2. This is going to be 2 squared. 4 times 3 is 12, so divide both sides by 12. So dx dt is going to be 10/3. On to number 5. X and y, let x and y be functions of time such that the sum of x and y, sum of x and twice y is a constant. So is a constant, so it's equal to a single number, the sum of x and twice y. Which of the following equations describes the relationship between the rate of change of x and the rate of change of y with respect to time? So now if I take the derivative of this constant, it's going to be 0. This is going to be dx dt plus 2 dy dt. So if I would solve for dx dt, we know that dx dt is equal to negative 2 dy dt. Let's go on to the next one. Let f be a differentiable function such that f of 3 is equal to 2, f prime of 3 is equal to 5. Use the tangent line at 3 to approximate 3.1. So if we write the equation on the tangent line, we need an x value, which is 3. We need a y value, which is given here, that's 2. And we need a slope, so my slope is going to be my derivative at 3, that's 5. So the equation of my tangent line, y minus 2 equals 5x minus 3. And we're going to approximate 3.1, so we're going to fill in 3.1 for x. So that we're going to have 5 times 0.1. 5 times 0.1 is 0.5. Add over your 2 to get 2.5. Okay, then for number 7, we have a limit here. So let's compare the limit of the numerator with the limit of the denominator. The limit of the numerator, we're going to go 2 squared, that's going to be 4. So g of 4 is 0. And then when we plug 2 into the bottom, I'm going to have 6 plus f of 2. F of 2 is negative 6, so this will also be 0. So the limit of the top is 0, the limit of the numerator is 0, the limit of the denominator is 0. So we can know that we can use L'Hopital's rule here. Derivative of the top, we're going to need to use chain rule. So derivative of the outside, copy and paste that inside times the derivative of the inside. And in the bottom, it's just power rule, 3 plus f prime of x. And now let's fill in again. So we're going to go g prime of 4 is still 0. No, g prime, not g. Sorry, g prime. G prime of 4 is going to be 5. And then 2 times 2 is 4. Over 3 plus f prime of 2 is 7. So we have 5 times 4, which is going to give me 20 over 10, which gives me an answer of C2. Okay, a thin rectangular sheet of metal expands in the hot oven. The instant when the width of the rectangular sheet is 200 millimeters and the length is 300 millimeters. The width, dw dt, is increasing at a rate of 2, and dl dt, the length, is changing at a rate of 3. At what rate is the area in square millimeters per minute changing? So the area for a rectangle is length times width. So as we take this derivative, we're going to have to go product rule. And then let's fill everything in. The length is 300. dw dt is 2, plus the width is 200. dl dt is 3, to get 600 plus 600, 1,200 for our answer. All right, now let's go on to this last one. Again, we have a limit here, so we want to check out the limit of the numerator and the limit of the denominator and compare them both separately, because 0 over 0 is not something that we can actually equal our limit to. So the limit as I approach the numerator, f of x minus 1. So f of 2 is 1, so 1 minus 1 is going to be 0. And as I plug in 2 here, that's going to be your sine of pi, and the sine of pi is 0. So we know that this limit is 0 over 0, so I can apply L'Hopital's rule. Derivative of the numerator is just going to be f prime of x. In the denominator, we do need to use chain rule. So the derivative of sine is cosine of pi over 2x times the derivative of pi over 2x is just going to be pi over 2. So I need f prime of x right here, which f prime of x is going to be its slope. Looking for good points here. We're going up 1, 2, 3 over 2. So my slope, f prime of x, is going to be 3/2. So I'll have 3/2 divided by, now as I take 2 and plug it in down here, that's going to be my cosine of pi, which is -1 times pi over 2. Now I'll have a fraction and a fraction, so 3 over 2 times my reciprocal, -2 over pi. 2's cancel, so -3 over pi. B is going to be my answer.